Okay, question 10, we have some exponential modelling. So, David has been investigating the population of rabbits on an island during a 3-year period. Based on data that he has collected, David decides to use the model R equals 50 e to the 0.5 t, where R is the number of rabbits and t is the number of years after the 1st of January 2016. For part A, using David's model, we want to state the population of rabbits on the island on the 1st of January 2016. So, at the start, t is equal to 0. That's going to give us r is 50 e to the 0.5 times 0. So, to the 0, e to the power of 0 is 1. So, we get 50. Part 2 wants us to predict the population of rabbits on the 1st of January 2021. So, in 2021, 5 years have passed, so t is equal to 5, which gives us r is 50 e to the 2.5, which to the nearest whole number is 609. Okay, then for part B, slightly trickier, we want to use David's model to find the value of t when r is 150 to 3 significant figures. So, we set r equal to 150, so we get 150 is equal to 50 e to the 0.5 t. Divide both sides by 50 and we get 3 is e to the 0.5 t. Now we need to get the t out of the exponential, so we take the natural logarithm of both sides. So we get log 3 is 0.5 t. So if we multiply both sides by 2, we get t is 2 log 3, which is 2.197 blah blah blah. We want it to 3 significant figures. Now our third sig fig is the 9, which has a 7 after it, so effectively that rounds up to a 10. So we get 2.2023 sig figs. Okay, then 10c asks us to give one reason why David's model may not be appropriate. So I can think of 2 things here. The time period that he's investigated the population over is incredibly short. It's only 3 years. So to make it more reliable, study the population over a longer time. And the other thing is that there is no cap or no limit to the model. So by the model, the population of rabbits is going to keep on growing indefinitely, which can't be true. So either one of those 2 and you would be golden. Okay, then for part D, on the same island, the population of crickets, C, can be modelled by the formula C is 1000 e to the 0.1 t, where again t is the time in years after the 1st of January 2016. Using both models, we want to find the year in which the population of rabbits first exceeds the population of crickets. So that's gonna happen. The rabbits have a faster rate of growth. So what we're gonna do, we're gonna set the two models equal to each other. So that's gonna allow us to find the value of t for when the populations are equal. Now technically, as soon as the populations are equal, because the rabbits have a faster rate of growth, a tiny amount of time later, the population of rabbits will be greater than crickets. So, setting them equal to each other, we get 50 e to the 0.5 t is equal to 1000 e to the 0.1 t. Let's divide through by 50. So we get e to the 0.5 t is equal to 20 e to the 0.1 t. Now, what we can do here is divide both sides by e to the 0.1 t. So e to the 0.5 t divided by e to the 0.1 t is e to the 0.4 t. That is equal to 20. Now if we take logs of both sides, we get 0.4 t is log 20. So t is equal to log 20 over 0.4, which gives us 7.49 to 366. So they are equal to each other then, almost 7.5 years after the 1st of January 2016. So the rabbits are first going to exceed the crickets in that same year. So 7 years after 2016 is 2023. So it's going to be about halfway through 2023. So our answer is 2023. Cool.